This is 3.6 Rational Functions, Part 1. We're going to start with a warm-up from what we did in 3.5, finding the asymptotes and intercepts of a rational function. So we're going to start by finding the vertical asymptote here. Vertical asymptote we always find by taking the denominator and setting it equal to 0. So when I solve for x, I get x equals negative 2/3. Then we're going to find the horizontal asymptote, which is when we divide the largest degrees. So our largest degree is x squared. There is no x squared on the denominator. So on top I have 1x squared, and on the bottom I would have 0x squared. Now when I take 1 divided by 0, you get a message usually in your calculator that's undefined. That's because you can't count, you can't divide by 0. So in this case, you would say that there is no horizontal asymptote. So if you ever end up with a 0 in the denominator, you just don't have a horizontal. All right, so then we find our x-intercept, which is when we take our numerator and set it equal to 0 and solve. So we would add 4. I didn't leave myself enough space. And then take the square root. So x equals plus or minus 2. And we write our x-intercepts as points. So negative 2, 0, and 2, 0. And then we need to find our y-intercept, which is when we put 0 in for all of the x's, which leaves us with negative 4 over 2, which simplifies to negative 2. And we write that as a point 0, negative 2. So we have 3 intercepts and 1 vertical asymptote for this graph. All right, moving on to some new stuff. It's something called a slant asymptote. So we have a vertical, a horizontal, and now we're going to have a slant, which is basically a diagonal asymptote. We have a slant asymptote when there is no horizontal. So in this situation up here, we found that there was a situation with no horizontal. That's when a slant asymptote shows up. We solve for a slant asymptote using long division. All right, so let's find a problem and give all of this a try. So here is our first example. X squared over x minus 1. We're going to go through all of those steps. I would encourage you to hit pause and try to go through vertical, horizontal, x and y intercepts. Do all that stuff that you already know how to do, and then come back and join us for the slant asymptote part. All right, so vertical, we set our denominator equal to 0. So we get x equals 1. Horizontal, we're going to divide our largest degree. So x squared is our largest degree. There's not an x squared on the bottom. So we have 1x squared over 0x squared, which tells us that we have no horizontal asymptote. So that's going to lead us to a slant asymptote later. But we're going to find our x-intercept first. So x-intercept is when you take your numerator and set it equal to 0. X squared equals 0. Take the square root, well, that just gives us x equals 0. So our x-intercept is 0, 0. And as we've talked about before, if you ever get the origin as your x-intercept, that means that it is also your y-intercept. So we don't have to solve for that separately, because it's both. Okay, so now we know that we need to do long division to find the slant asymptote. So we're going to take x minus 1, that goes on the outside, x squared on the inside. So we see how many times does x go into x squared? Well, that's x times. And then we're going to multiply x minus 1. I'm sorry, x squared minus x. I did a terrible job multiplying that. We're multiplying x times x minus 1, but when we do that, we get x squared minus x. And so we divided, we multiplied. Next we would subtract. But notice that we don't have anything here to subtract. So let's put some placeholders in. Plus 0x plus 0 as our constant. So 0 minus a negative x gives us a positive x, and then we bring down. And we divide again. X divides into x one time. We then multiply x minus 1. It is x minus 1 that time. And now you're going to subtract. 0 minus a negative 1 is a positive 1. Okay, so after we do the long division, normally we take the remainder and we stick it up here and we put it over what we were dividing by. Not in this case. We don't care about the remainder. So you can just cross it out. The only thing we care about is this stuff on top. We're going to take it and state our slant asymptote as y equals, and you have to put that y there, x plus 1. So the x plus 1 comes from this part on top, but make sure you put y equals. Okay, so we want to graph this. We have our vertical asymptote at x equals 1. So I'm going to put that vertical asymptote in there. We have no horizontal. We have an x-intercept at 0, 0. And then we want to graph this line, y equals x plus 1. Well, let's review how we graph a diagonal line. This is in slope-intercept form, y equals mx plus b. Remember that the m stands for the slope, and the b stands for the y-intercept. So in the particular one we're working on, we have a slope of 1 and a y-intercept of 1. So we start with the y-intercept. You'd start at 0, 1, and you go up 1 over 1, up 1 over 1. That's how a slope of 1 would work, up 1 over 1. So here's this dashed line for our slant asymptote. Then, like all the other ones we have done, after we put that information on there, we need to find some additional points. Same rule applies. We want 2 points to the right and 2 points to the left of that vertical asymptote. So our vertical asymptote was located at x equals 1. So we want 2 points to the left. We already have 0, so we can do -1 and -2. And then we want 2 points to the right, 2 and 3. So -2 equals -1.3, -1 is -0.5, 2 is 4, and 3 is 4.5. And all of this is in the directions, so let's find all the asymptotes, the intercept, and use some additional points. So here's our additional points. So make sure when you are doing this that you are showing all of your work and you have all of this information. So -2, -1.3, -1, -0.5, 2, 4, and 3, 4.5. All right, like our other graphs, we're really going to use our asymptotes to help us out here. So this one, there's 3 points. We're going to use the slant asymptote and come along the slant asymptote, go through the 3 points, and then turn and go along the vertical asymptote. That's our bottom branch. On our top branch, we're going to use our vertical asymptote, come down, pick up these 2 points, and then go along the slant asymptote. Last thing we want to do is find domain and range. Domain is our x's. It goes fine until we hit our vertical asymptote, so -∞ to 1, and then picks up again on the other side of that vertical asymptote. And then our range, there's no horizontal to stop us, so we go -∞ all the way up to 0. That's kind of our topping out point there, with a bracket because there is an actual point at 0. And then here our bottom point was at 4, so it picks up again at 4 and goes to infinity.